Welcome to the review for the exam. I'm going to be working through the problems on the sample test. This is Jane Smith, one of your instructors, and I'm going to go through and we'll do some of the problems on the sample exam. The first problem says the function f of x equals x over x squared plus 4. You want to know where it's both increasing and concave down. So that means I need to set up two number lines. So first of all, we look at f prime of x, and we find that we need to find our critical numbers. Critical numbers occur where f prime of x is equal to 0. And so we look at that derivative, which is given to us, and set it equal to 0. And we see that 4 minus x squared equals 0. So x equals plus or minus 2. Make sure you get both of those values. Okay, and secondly, we see where f prime of x is undefined, which would be where the denominator is equal to 0. Remember, a fraction is equal to 0 when the denominator is equal to 0, but that doesn't happen. We're adding plus 4 to x squared, so no matter what x is, you'll have a positive value. And so when we set up our number line for f prime, we see that we're just going to have the values negative 2 and 2. And just as a reminder, I forgot to mention this earlier, the domain of my function is all real numbers, because the denominator of the original function is x squared plus 4. So it is always defined. And so the only values we have to consider are negative 2 and 2. F prime is 4 minus x squared over x squared plus 4 squared. And you put in your trial points in each of the intervals determined by those critical numbers. And we see that from 2 to infinity, that's going to be negative. Okay, just plug in. The denominator is always positive, just plug in for the numerator. If I plug in 0, I see that numerator is positive. If I plug in negative 3, I get 4 minus 9, it's negative. I'm going to do these steps quickly, but you need to make sure those are correct, because if they're wrong, the rest of the problem will be wrong. Okay, so then f, what does that tell me about the function? It tells us where it's increasing and decreasing. So that's what the function is doing. Okay, now we do the second thing. We do the same thing for f double prime of x. Make sure I've got it here so you can see it. So f double prime of x. And again, we set f double prime of x equal to 0. And that's where the numerator of that derivative is equal to 0. So 2x times x squared minus 12 is equal to 0. So x equals 0, or x equals plus or minus the square root of 12. The square root of 12, 12 is 4 times 3, so it's plus or minus 2 square roots of 3. That's going to be important when we compare the two number lines. Okay, and of course, f double prime of x is also always defined. So on our number line for f double prime, we're just going to have minus 2 square roots of 3, 0, and 2 square roots of 3. And that derivative is 2x times x squared minus 12. Again, the denominator is always positive. So if I use my trial points here, certainly 3 is going to be, let's say 5. That'll be larger than 2 times the square root of 3, and that's certainly going to be positive. If I plug in 1, for example, I will get a negative value. If I plug in negative 1, x is negative, so I have 2 negative values, it's actually positive. And then if I plug in a point to the left of minus 2 square roots of 3, I get negative, positive, so it's negative again. So I know that f double prime tells us about concavity, so the function f must be concave down, up, and up, and these would each be inflection points. That's not what's asked for, but we can see that. Okay? And then we have a min and a max. So now the question is, where is the function both increasing and concave down? Okay, so now I just look at my two number lines. I want it to be increasing, so it's got to be between -2 and 2, and also concave down. And if I look at the two number lines, I see that concave down starts at 0 and increasing ends at 2. So if it's both increasing and concave down, it's got to be the interval just from 0 to 2, which actually got erased in mine paper, so the answer would be 0 to 2, which was choice C. Okay? Hope that's helpful for you. Let's look at another example. Let's write the equation of the tangent line to the function. Yeah, set that up a little bit higher so you can see it better. Trying to adjust here. There we go. So we want the equation to the tangent line of this function. And remember, the derivative of e to a function of x is just e to that function times its derivative using the chain rule. Okay, you do not change the exponent, you just repeat the function and multiply by the derivative. So f prime of x is going to be, in our case, e to the square root of 4x minus 3 times the derivative of the square root of 4x minus 3. Okay, so that's going to be e to the square root of 4x minus 3 times 1/2 4x minus 3 to the negative 1/2 times 4. You got to remember to use the chain rule there, because keep in mind this is 4x minus 3 to the 1/2. So we use the chain rule there. Okay? And so if we like, we can see that f prime of x, simplifying that, the 2 will cancel with the 4. It just leaves me a 2. And the power of e in the numerator, and in the denominator, that square root will come down. Okay, so now the question is, what's the equation of the tangent line? So first of all, I have to find the slope of the tangent line, and that's just f prime of 1. So that's 2 times e to the square root of 4 times 1 minus 3 over the square root of 4 times 1 minus 3, which is just 2e to the first over 1, or 2e. And that's okay. Don't get thrown off by that. That's a perfectly valid number, and so that will be our slope. The second thing we have to find is a point on the line. Now we know when x equals 1, the y value is going to be the function value on the original curve. Okay, remember the tangent line and the curve intersect at that point. So f of 1 will be e to the square root of 4x minus 3, which we know is, e to the 4 times 1 minus 3, which is e to the first, which is just d. So our equation is just y minus e equals the slope 2e times x minus 1, because this is the point 1e. Okay, so y minus e equals 2ex minus 2e, and if I add e to both sides, plus e, okay, then I get the final answer. It is a linear equation. Okay, are there any questions? Hopefully that's going to help you. Okay, let's look at the next problem. Again, let me get this oriented right here. I'm not the most experienced at this video taping, but learning. Okay, so here's the situation. You've got a stone dropped into a pond, and it creates ripples, okay? And so here's where the stone lands, and what's increasing are two things: the radius of that rippled water plus the area. Okay, and when you're doing a related rates problem like this, that's the first step, is to set up a picture and your variables, and then to determine what it's asking for. So we jump immediately to the second part of the question, which says, at what rate is the area increasing? So rate, we know, is the derivative. So it is saying find the rate of change of area with respect to time. It tells you that. Related rates problems are as much about reading as they are about mathematics. You're just reading what it says, okay? Now, with what information? What we know is that the radius is increasing at a constant rate of 3 feet per second. That's the rate of change of radius with respect to time, and that's equal to 3. So now we have our rates, and we want to relate them. So the second step, of course, is to find an equation that relates the quantities. And this problem, where we're nice to you, is just the area of that circle, which is pi r squared. And then the third step is to find an equation relating the rates, and that's when we differentiate both sides with respect to time. Okay, and when we do that, what do we get? dA dt on the left, and we get the derivative of pi r squared is just pi times 2r with respect to time. I have to use the chain rule and multiply by dr dt. And so dA dt is 2 pi r times dr dt. Okay? Now what do? Now we plug in. We know that dr dt equals 3. And we're also trying to find how the area is changing at the instant when the radius is 5/2. The radius is always changing, but we want to zoom in on the instant when it's 5/2. Okay? And so then we just plug in. And dA dt is 2 pi r, which is 5/2, times dr dt, which is 3. So it is 15 pi. Okay? Now, what does that mean? What that means is that the area is increasing by 15 pi, what? 15 pi, now area, okay, our units are feet per second, but area is square units, so it's feet squared per second. And if that's not given to you, this was a multiple choice question, but if it was on the tear-off, we would be looking for that answer. Area is increasing by 15 pi feet per second. Thank you. We'll do a few more in a few minutes. Thank you.